Hi, I'm Robert Rose, CEO of Reliable Robotics. I'm also a pilot, private pilot, a low-time private pilot, working on my instrument rating, hope to have that very soon. I started Reliable Robotics about 6.5 years ago with a mission to improve aviation safety by adding more advanced levels of automation to aircraft.
AOPA keeps flying safe, accessible, and fun by protecting your freedom to fly. We are the most trusted one-stop resource for all things related to general aviation. Become an AOPA pilot today.
The company came about actually when I was taking flying lessons. I flew a lot with my mom when I was a kid, did Civil Air Patrol, and she taught me to fly, gave me an appreciation for the art and science of flying. And I wanted to take flying lessons when I was a kid, but it's an expensive thing to do as a hobby. And so it wasn't until I was an adult I started taking flying lessons again, and it was that very first trip up in the pattern at San Martin, actually, where I was really surprised how little aircraft had changed in the 25 years since I first flew with my mom. And I started to investigate, well, why is that? Why don't we have more automation in aircraft? It struck me as a little silly, I guess, how antiquated many systems are, and that people are expected to not only maintain wings level on approach, but also manage the engine and keep track of the navigation state of the aircraft and communicate on the radio. And there's dozens of things that you're expected to do simultaneously. So I was looking for answers to, well, why haven't we added more automation to aircraft? And it was through the exploration of that question I concluded somebody needs to start a company that builds safety-enhancing equipment and start putting them into aircraft. And we need to do it now, and we need to do it in the United States. So the way our system works is there's a flight management system, much like what you would have in an aircraft today, except our flight management system doesn't allow you to specify any discontinuities in the flight path. Every flight path has to result in the aircraft landing at a runway. So your responsibility as the pilot is to do much of the same things that you would be doing today, especially if you were operating under instrument flight rules. You're filing a flight plan, you're talking to air traffic control, you're monitoring the weather, and then you're communicating with other pilots and stating the intent of what the system is doing. So we recently flew our Cessna 208B Super Cargo Master out of Hollister Airport with no pilot on board. It was a 12-minute operation, including taxi, takeoff, and landing, from humble beginnings, but it was significant in that the pilot was not on board the aircraft. We had been preparing for this flight for many, many, many years, and we've had a lot of back and forth, obviously, with the FAA with respect to our safety analysis and procedures for running this operation. The operation went off exactly as we expected it to. It was completely uneventful and normal. Nothing exciting happened. In preparation for this, we ran dozens and dozens and dozens of flight tests, as well as, I would say, hundreds of thousands to millions of simulations to ensure that the aircraft would perform the way that we expected it to in all foreseeable operating conditions and perhaps anomalous conditions. The system does have redundancy. We did not need to engage the redundancy for this operation, but we were ready to use it if necessary. The remote pilot was sitting right here behind me, and they had an interface terminal where they could send commands to the aircraft, programming it much like what I described earlier. The remote pilot has a menu of options that are given to them, and you might choose one of these options for traffic deconfliction reasons, for example, would be the most common one. There may be a runway incursion incident. You may need to do a go-around, so you have an option to program the aircraft at a very high level to take another lap in the pattern. You also have the radio. So we have a mechanism here where when you push to talk, your voice is then streamed over satellite to the aircraft and then is broadcast out the aircraft. The remote pilot also has the ability to hear everything the aircraft hears. So the radio programming is echoed directly over here. It works exactly the same way it does today. It's just you're not in the plane. So you can dial in a frequency, push to talk, and then listen on that frequency. There's no joystick, there's no yoke, rudder pedals, nothing like that. You are programming the aircraft. And this is important because latency concerns, there's a number of practical reasons why that is a very, very hard technical problem. I also don't believe it's the right path to take. I think it can be used as a crutch. We are developing an autopilot that is good to 10 to the minus 8, which means 1 in 100 million hour mean time between failure, which means we need an extremely high level of redundancy, and we need to consider all of the what-if scenarios that with an autopilot today might result in hitting AP disco and manually flying the aircraft. We don't have that option. There is no AP disco from the control center. So the system needs to be able to manage all of those contingencies internally. And that's hard. It requires pulling from many standards that are used in Part 25 fly-by-wire systems. Like there's an AP disconnect in a large Part 25 aircraft usually, but you can't turn off the fly-by-wire. That's always on 10 to the minus 9. And our system is designed much the same way.